I have started streaming and yeah, it has started. I'm sharing you the link, just check, right?
So where did you send the Google Meet or have you
No,
DM me?
Google Meet only.
I just got the link. Live. Yeah, seems like we are live.
Okay, let me put it on full screen. So it's on full screen, right? Okay,
Okay. So far so good.
right. Yeah,
So hi Akhil.
yeah.
Hello everyone.
Hi Aditya and hi everyone. So we will be continuing our yesterday's research paper or white paper, whatever you can say, and we'll be starting from the beginning. And I think we should also thank the authors of the research paper, Vijay, Yang, Fang, whatever, Matthew, Moritz.
Yang Bang.
I'm,
कहाँ पे
I'm
रहा?
not I'm not demeaning them, but like it's very rhyming word, and and we tend to find one Indian name and one Chinese or Japanese guy in all of the research paper, whatever we scroll down. So, so continuing in that streak, so we'll be today exploring how Netflix, uses multiple CDN networks, sorry, multiple CDNs to deliver their content. So, Aditya, can you briefly explain about the abstract and then we'll go to introduction part?
Yeah, sure. So notice leading provider on demand Canada, Canada, and design peak downstream traffic in US. Design performance, light home goods. So in the like abstract saying that the 29.7% of the overall downstream traffic.
Right.
Downstream traffic is basically it means when someone is receiving data from the internet. So that's
Okay.
downstream, and
Okay.
that traffic is so overall of that traffic, 30%, around 30% is on Netflix itself for US. And later it says like how there's a blend of CDN for the distribution of the various movies that you watch,
Mm-hmm.
movies, web series, TV shows, etc. And finally, the improvements on the CDN and how they are strategizing to move towards multi-CDN setup, which will ultimately make the movies or streaming more viable and faster. So
Okay.
that's the whole abstract about. Basically, we'll be talking more about the CDNs and how the video actually reaches your web browser, and then how you are able to watch it across different web browsers of different versions of different systems, OSs, etc. All seamlessly same.
Okay. And one more thing that this paper is going to, like propose solutions that how this multiple CDN can be optimized to give you more throughput. So that's about that and
Yeah.
increase the user's average bandwidth. So the paper first suggests about how the Netflix really works and how it uses multiple CDNs to leverage. So how it leverages multiple CDNs to deliver their content to you, and once it finishes that, the researchers suggest how they are, trying to utilize few of methods to get more bandwidth from the existing CDNs. So majorly, so I'll try starting the introduction part. So as average bitrate reaching of Netflix is 3.6 Mbps, and Netflix is the single largest source of internet traffic in the US. So it consumes around 30% of peak downstream traffic, and so these highlighted parts are the major, like pointers which we have extracted from the white paper. And so Netflix has resorted to the use of cloud services, content distribution networks, which are CDNs, and other public computing services. So Netflix majorly relies on Amazon. for their cloud services like Amazon AWS cloud in replace their infrastructure. So earlier Netflix was using their own infrastructure, but later on they have shifted to the AWS, and they are using Amazon SimpleDB, and S3 and Cassandra are used for file storage. As we know that S3 is like your regular disk drives which are stored in cloud, and Cassandra is, I think, non-relational database, right, Aditya?
Yeah, it's a blend basically. It's relational database as well with columnar data, and also it's out of the box is distributed. It's designed to be
Oh,
distributed,
okay,
so it
okay.
has multi nodes
Okay,
out of the box.
okay. We can talk about Cassandra in detail in some other video. And so thanks for the
Yeah, sure.
input, Aditya. And video streaming is served out of multiple CDNs. So what do we mean by multiple CDNs? There are multiple CDN providers. Like there are multiple cloud providers like Google, AWS, and Azure. So similarly, there are multiple CDNs like Amazon provides it, Akamai provides it. There is level 3 which provides CDN, etc. And Ultra DNS, a public,
Cloudflare.
yeah, Cloudflare provides CDN, right, right. And Ultra DNS, a public DNS service, is used for authoritative DNS servers. So the DNS means domain name servers, which resolves our DNS. Microsoft Silverlight is employed as the video playback platform for Netflix desktop users. These few terms will be repeated multiple times in our newspaper, like the news saying white paper, the Microsoft Silverlight and the CDNs. So, going to our next pointers, which are about, there will be a few jargons which we will be using, and we'll get to know about them from Aditya's perspective as well. Possible blueprint for a scalable infrastructure less content provider. We discuss on CDNs and distributed after streaming. Analyze the algorithm used by Netflix so it is a glue to piece together all our system. So architecture of the Netflix video streaming together with the extensive measurement study of 3 CDN it employs. So the main contribution of this paper can be summarized as the followings: that we dissect the basic architecture of the Netflix video streaming platform, how it, as we already said, that how the video is delivered to you, and we analyze how Netflix makes use of the multiple CDNs under changing bandwidth conditions. So suppose you are traveling in a train, or like traveling in a car, and so your internet is fluctuating. So your bandwidth is basically fluctuating, and how it is handled by Netflix to deliver you content. And another is significant variation of CDN performance across time and locations. So the research paper also observes and results. They have done few research on this, that how the CDN's performance is changing based on time and location. Finally, they are exploring multiple strategies and alternative strategies to make it more efficient, and like deliver you higher bandwidth. So that's about introduction part of the paper, and now we'll be moving to section 2. Section 2 and section 3, which majorly describes about how the Netflix architecture works. And you can see there are few key Netflix host names in the table, where it is being hosted. So the netflix.com is in the Netflix organization, where there is own IT infrastructure. Rest of there they have outsourced. So they are using Amazon, they are using level 3, Limelight, Akamai. So over to you for the uh, further section, Aditya.
Yeah. So the section two. Let's skip this part. Section Netflix video streaming platform.
Okay.
Since we start a section with the overview of the Netflix streaming platform and its asset, traffic monitoring destination. Who is lookup? I'm just reading through that only. The Netflix video streaming platform,
This
and
one, right?
yeah, yeah. So,
Okay.
look up different timeline of the saving single Netflix for example, let's interplay with Netflix player and media service numbers to contact video services and tempered data add on and less client sequence parameters finally focus on Netflix area assignment strategy in individual cities bandwidth will discover how Netflix makes it. So here it describes like how what we'll be walking through basically
Mm-hmm.
over the different traffic monitoring, DNS resolutions, and who is lookups. So we'll get to these terms later. And
Okay.
so these are the parts, and then how the CDN, how Netflix assigns CDNs to client. Basically, we get to know that it is using multiple CDNs, like maybe three vendors, like Akhil said, the S3, Amazon's CDN, and then Cloudflare and level three. So it typically sends some manifest file from the client, and which based on the bandwidth and the network the client is streaming on, it ranks the CDN and like basically assigns a CDN to that particular client for the fastest retrieval of data.
Okay.
Overview of the yeah. So that was that. Overview of the Netflix architecture. It was the basic server. We create a new user account, log into system, movie monitor, traffic and record hosting of the server and the process. We then perform DNS scanning, collect the current names, names, and IP address of all the servers whose browsers have connected. We also perform who is request the IP address and our owners. TO server was the relevant hostings owners and so it records the key components. Yes. So here it's basically saying whenever we are the Netflix has different host names that we can see in the table one
Hmm.
that was described earlier, and the different processes is set to different servers basically. So the first one was the www.netflix.com. It's their own server. So whenever we hit to www.netflix.com, every request goes to that server, and later on the login part and login, and then yeah, login sign up, these parts are handled by the this Akhil, can you just move a little bit to the table, move it to the table before. Yeah,
Right,
so
right.
it
This
moves
one.
to the sign up platform, that's for Amazon, and for fetching the data, like what the metadata for the video that we are going to watch. Basically, when we click a link to a video, so there are some information apart from the actual video playing, like the movie name and the what the title and the cast and everything. So those information are going to be fetched from the movies.netflix.com, which is again hosted on Amazon, maybe an EC2 instance or something like that, and so forth, so on, so forth. So different. Then finally, the movies are going to be served from these three CDNs, that is level three, Lamnet, and Akamai.
Okay.
And
So
yeah.
they have I think you have discussed till this point, sir. So Aditya, I would like to ask few, jargons which are here. That we often see C names while we try to host, if someone tries to host their website on internet. Can you tell us about canonical names, C names? What are those? If you have anything regarding that.
So yeah, maybe I have to also learn that little accurately. But
Hmm.
canonical names on high level is basically we apply for names, right? So
Right.
what happens? There are 13 servers which assigns like .com, .net,
Hmm.
.edu, etc. So there are set of 13 those servers. They are called root servers, and they are like placed everywhere strategically across the globe. But
Okay.
there has to be these 13 servers, and we have to like get IP address from those servers. Basically, not IP address, like how we can say that. Uh, yeah, let's say some IP addresses that gets assigned from these servers, and this whole IP address assignment, or like the buying and selling thing, happens in like GoDaddy or whatnot, Namecheap and whatnot. So these is handled by ISN. What's that authority? I'm forgetting that name.
For.
International some service for like this authoritative name service,
Okay.
ISN
Okay.
or something like that.
Yeah. Yeah.
So
Got
yeah,
your point.
and they basically so coming back to the canonical names, so they have assigned some IP address, right? But we cannot ask the users to go to 120.0.4
Right,
dot
right.
27 Netflix. So here comes the domain name buying part that GoDaddy or Namecheap offers. So what they do is they bind that IP address to basically they don't bind the IP address. They just provide us a name that okay, this is a domain name, and we will register it with the global DNS resolution maybe or the ICANN like whichever resolves that name to give your given IP address. Basically, this is give me your IP address and this is a domain name and I'll map it together.
Okay, okay.
So
So,
yeah, so this is how the domain name wala part works. And back to the canonical links. Now we have like Netflix.com to our end, right? Now we can have so how this works. Let me get back to my note. Uh, um, my video is not visible, right?
it is
So
visible.
the
It
phone's so the phone's camera is visible. Are you able
right,
to see the note? Okay, okay.
right, right. Let
So
let
what happened?
let me like full screen the paper one first.
www.netflix maybe netflix.com. So this tracks backward. So here we have a dot that is a root server.
Okay.
Basically, you can say that's the end part of the internet. And now we have .com. So .com comes from the 13 these 13 pre-assigned root name servers that is globally
Mm-hmm.
distributed. So for .com and .net,
Dot.
.ud, so they will
Okay.
have their own what internet not IP, but we know that there are ABCD and different types of that IP is distributed across different ranges, right?
Right, right.
So yeah. So .com wherever we want to fetch the .com, so it will point yeah this is your server and this will result some IP address or some maybe some bytes. We don't know. And now it will find Netflix. So Netflix again it will go to ISN or whatever
I
it is.
C A
Then it
double N.
will
I can.
I can yeah
Yeah.
I can right.
Internet
So
Corporation
I
for assigned names and numbers.
Right. So this will bring us some IP address again for Netflix, and then dot www dot sorry www dot. So that will be the last. Now what we can do? We have this. We have bought Netflix, right? Domain name. So we can add something like Aditya dot Netflix .com. This is valid. Now I can
Okay.
configure this to some other service. I will have a different IP for this. And similarly, I can have akhil.netflix.com.
Mm-hmm.
So this is called canonical name servers.
Okay.
This can be configured at the what the business end, like at our end
Okay.
we can configure this does not require any standard operation or this does not require any like paying like by we have bought this Netflix domain name from some GoDaddy or Namecheap, so this doesn't require anything. We can just have this
Okay.
canonical name on our server and we can feed it to the route 53 that is DNS resolution which resolves this name to some IP address. So we can say, yeah, point this aditya.netflix.com to some our EC2 instance, maybe EC2's external public IP.
Okay.
Public IP.
So once
So
we
now
buy
we
the
are
domain, then we can configure our CNAMEs according to us. So,
yeah. So
so
the canonical names is that like the pre part that is meet.google.com. So meet
right, right.
that.
Okay. So for
So
any n number of products, they can just configure their
uh,
product name as their
yeah,
canonical names.
and also this can grow like anything. Like we can have also like
Okay.
aditya.pramanik.netflix.com.
Okay.
So
Okay.
again, this can have its own server. It can solve a different purpose altogether. So this is how it goes.
So
Maybe now it's a good time to Google it, like what exactly canonical
right, right,
names
right,
are.
right. No. So sure, sure. So I am again. Just give me a second.
Yeah.
Yep. So uh, let me unpin your pay copy first, and
Yeah, yeah,
then
sure, definitely. Like day before yesterday or 2 days ago, I think I was going back to these things like the ICANN and the whole
right, right,
domain
right.
name system, IP and addresses and everything. So whatever we have learned across the like in the syllabus of our engineering, so that was overly simplified. So that's where like we mess up sometimes because in the actual world it's not how simple it is. There are distributed systems. There are enough number of routings. Yeah.
So a canonical name is a type of domain name system database record that indicates that a domain name is a nickname or alias for another domain name. Also referred as the true name, the CNAME is especially important. Okay. So there are multiple, I think, names which could fetch to the
Okay.
same.
So the IP.
This is the
Yeah.
C name, right? So this C name www.target.com will point to the same tag target name, and this tag target name will like point to the IP. So
The actual IP. Yeah.
suppose there is one more C name which we can create TT, and that will again point to the techtarget.com. So I think that is that C name. So there will be multiple names which will be pointing to the same server. So I think that is
Mhm.
about that.
Okay.
So if we are opening
Yeah.
Amazon US, Amazon.in, Amazon, etc., that will be opening an Amazon site, something like that, I guess. So if I'll try
Mhm.
canonical searching for canonical names of Netflix, then I think that will be more clear to us.
Mhm. Yeah.
List of original, no, no, no.
Canonical names.
Canonical. I think
C names.
I
Can you
should
try
write
to
C
see?
names. Right.
Canonical is going for actual canonical
Yeah.
name.
Okay. Let me Google it. I don't trust Bing that much.
Being search is
So Bing is like Gemini of Google. List of original. This is giving us same result, I think. Let me ask ChatGPT, I think.
ask Copilot is saying instead of ChatGPT.
What are C names?
Canonical.
C names, and can you provide few C names of Netflix.com? So yeah. So these all are a few examples here because Netflix might be okay. Okay. So if I try opening this, then what will happen?
I don't think you will be directly able to open that because
I think this is for CDN, API Netflix.com backend service or user authentication.
but I have a question like can you ask ChatGPT like how if the names are different but it still points to a same server, then how server is going to differentiate whether what purpose because server is doing same thing like if someone hits that IP address it will result into a set of specific things but based on name how we can configure it to do multiple things
Mm-hmm.
with same IP. You got
Okay.
my question right?
Yeah, I got your question, but let me read once again what definition the of C names the ChatGPT gives. So the canonical names are a type of DNS record used to alias one domain name to another. So this allows you to create multiple domain names that all point to the same IP address or web services, simplifying the management of DNS records. A CNAME records essentially tells DNS that one domain is an alias for another. That we have figured it out. For example,
Yeah.
if you have website at example.com but you want to point same location, okay, you would use CNAME to make an NDR of okay. So if that is the point, then these are like invalid.
Yeah, because they will at the end they will directly point to same IP address. So
Yeah.
like we are unable to
If
differentiate the
if all the C
what
names
processes.
points to the same IP address or web service, then how does server differentiates their functionalities, right?
Yeah.
Great question. While CNAME records point to other domain names and not directly to IP address, the server still differentiates based on host names, okay, domain themselves, and pathways defined by the
Okay. Okay.
application. Here's the breakdown. CNAME points to a domain name, not directly to an IP address. Okay. CNAME points to a domain
Okay.
name. Record points to another domain and might point to global. Okay, but it doesn't. It's a linked list kind of thing, but it does not provide the IP address. The name will eventually resolve the CNAME to an IP address, but the CNAME itself is
Okay.
just an alias. Host header in the API is
So
virtual listing path. It's a pretty.
maybe it's like that. Like, have you seen the configuration file of Nginx?
Yes, I just saw today only. I was working on that.
Okay. Yeah, that was okay. That's a great coincidence. So in there you can see like first we declare what is the host name, like where it will where from where we will be serving the files, and later in the like load balancing part, it requires us to like point the actual servers that will be like from where we'll be getting these requests, right?
Okay,
Something like that.
let me
Maybe
open.
in that particular.
Let me open this for better understanding. Talking about this conf file or
Okay.
something other conf file?
Yeah, this one. Okay, okay. Yeah, proxy. Just around that, below that, a little
You are
more.
talking
Yeah,
about this,
okay.
right?
This one, yes. So we are saying listen1.example.com. So here we can have Nginx setup for a different CNAME itself, and then we
Right.
can have these proxies set up. Like this is the IP for that, maybe
Okay.
like
Yeah.
something
Yeah.
like
This
that.
proxy pass, right? So,
Yes.
okay. What I understood is that suppose I'm writing here only. Let me zoom in. So Aditya is pointing to Aditya Pramanik, and Aditya Pramanik is pointing to suppose college canteen, and college canteen is pointing to cc.com, right? So if I'll search Aditya, it will point to this, and this 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 will point to this, and ultimately it will reach to our website if there are. So I think that is canonical names for what I understood about it. So you can see this, right? So Netflix.com is pointing to the global CDN Netflix. API Netflix is again pointing to this only. NFLX at video.net is also pointing to the same global CDN Netflix.com.
Yeah, but again, server has to know like the maybe api.netflix.com only is going to send all the HTTP requests API
Mm-hmm.
gateway for all the HTTP requests, and then Netflix.video.net must be the CDN of the actual videos that are stored, maybe S3 link for those CDN video URLs.
Yeah,
So
here are the details
Nginx
for
or
that.
something in the middle that should say, yeah,
Mhm.
this is the service name, a canonical name, and this functionality is going to serve. Although they have same IP address, so there has to be something in the middle, maybe Nginx or don't know
Yeah,
what service we are
a
missing.
request address will contain the host information, and that
Host name.
host
Okay, it's
information, yeah,
differentiating based on the host name. Okay,
host
okay,
information, and that
yeah.
host information will tell us what to do and what not.
Okay.
So
So
that is
although we have
about,
same like IP address for for both the machines, but still we'll be able to differentiate by the host name.
right.
Just like just like in the case of just the complete opposite happens in case of these the front end and back end. So when we search, let's suppose www.netflix.com. So
Mhm.
that name uh, opens to it points to front end, but in the front end maybe it's a React code, and then it calls some APIs. They're also then again we are calling the same different machine, but on the same
Same
that
server.
www.netflix.
Right, right.
So maybe in
Yeah,
contrast to that, we can understand this.
right, right.
Okay.
So there are four
So
key
that
components: Netflix data center, Amazon cloud, CDNs, and players. So Netflix data centers are the only thing that Netflix manages by their end, and rest are,
mhm,
like outsourced. So Amazon cloud, AWS, CDNs are of
mhm.
multiple vendors, and players is of Microsoft Silverlight, which we are considering for the research paper only.
This is very
For
right.
the desktop streaming only, we are seeing this research paper. So, okay, want to tell us about Netflix data centers?
Netflix data centers.
So, aren't that
So I
Netflix?
don't know much.
No, just
I don't know
what
much
is in
about
the white
Netflix
paper.
data centers.
No, whatever is written on this paper only. So,
Okay, okay. This paragraph. Okay,
right,
the
right.
Netflix data centers. Our services Netflix uses its own IP address as the host name Netflix account. The server primarily handles the key functions, registration of the new accounts, capture payment information, credit card, and this one redirect users to movies.netflix.com. Okay. So basically, and then sign up based on the whether user is logged in or not. Respectively, the server does not interact with the cloud during the playback. Okay, so the Netflix data center, it's basically, as you can see, divided into three parts: the login, sign up, and the payments, and the very first front page of the Netflix. So these are the areas which Netflix, their own infra, takes care of, and everything else like the video, the actual video that we are playing, it's served from some another service. Like we just saw, like maybe it can maybe from the CDN, or yeah,
Right,
generally from the CDN, and everything else is from the
right,
this EC2 Amazon's cloud. So
right.
that was that.
It's
Now
pretty,
coming to
like,
the Amazon. Mhm.
it's pretty. You log in, you save your credit card and debit card info, and then they redirect to different thing.
There, right. Then Amazon cloud part. Except for the www.netflix.com, which is also Netflix, most of the others Netflix servers such as AG Movie Control Netflix and Movie Netflix Control are served for the Amazon cloud. Indicated that Netflix uses various Amazon cloud services ranging from EC2, S3, SDB, Simple DB, WPC, Virtual Private
Cloud,
Computers, Virtual
cloud,
Private
cloud,
Connectors,
cloud.
virtual private clouds, and key functions such as content ingestion, log recording analysis, DRM, CDN routing, user sign in, and mobile device support, all are done in the Amazon cloud. So this is a major highlight of the how Amazon is being used by the Netflix. So all the DRM protection of the video, CDN routing, what URL should hit when you click on a video for that from the CDN. So that's, and then user sign in, and different mobile support. So I guess from the different mobile support, it seems to be like different range of qualities from like HD 4K, and for some mobiles it's HDR is also available, and then bit rates, different bit rates maybe based on the how latest for handset you have, or how old handset you have. And then, and yeah, then the movies part, movies.netflix is also hosted in the Amazon cloud. Then CDNs, Netflix provides multiple CDN for delivery video content end user. Then the encoded and DRM protected videos are served in the Amazon cloud and copied to CDNs. So what this so how CDNs are basically used is m- like Netflix, they own some TV show, maybe Breaking Bad, and that Breaking Bad video, or maybe multiple videos, they are encrypted. Encoded means encrypt. We can assume it as encrypted, because it's not like you have that file and you can read it on your machine. It's not like that. So that's where the DRM protected thing comes in. We will get into that right after this, like what is DRM protected videos and whatnot. So these video chunks are saved, video files are saved to S3, and then S3 link is provided into the CDN so that it can like fastly fastly send to the these end users. And yeah, so that's that. Now coming back to DRM and video encoded files. So Akhil, maybe do you want to add to the DRMs and what are like
Yeah,
how it
so
works and what it do?
DRM, as far as I know, that DRMs are digital right management thing. So it protects you from, like your digital rights are protected, that this is yours. If you someone is cannot stole that. And encoding and decoding is basically like you can draw parallels with the encryption decryption, but encryption decryption are a little bit more complex than encoding decoding. So encoding decoding, we can create our own encoders and decoders. And if you have some particular software, if you'll go our encoded thing through that code, then it will be decoded. There will not be any external, like keys or SHA keys, RSA extract are needed, I guess. So you have also heard of that
Hmm.
base 64 encoding, and all sorts of encoding algorithms you have heard about. So we can encode media to different kinds of encoding, decoding. I am not recalling any encoding algorithms as of now, but that is about encoding. And so I know that much only about DRM and this Aditya.
Okay, so for DRM, I would like to add more things. So you are absolutely correct. Like it manages the copyrights. Basically, like you are watching some, you have paid subscription to Netflix, and you are watching some movies or TV shows from Netflix. But it's not like you have all the rights to exploit that movie,
Right,
resell
right, right.
that, maybe record that and send it to your friend and let them make it watch. Or you can just have your own digital copy of that movie, and when like you can end the subscription of Netflix and you still have that video. So to avoid all these things, what DRMs comes into play. So DRMs, so what it helps, it basically so the videos are DRM encoded videos. They cannot be recorded, and they cannot be like watched as we can watch any video using our video players like VLC media player or any built-in media player. So they cannot be directly run. They need to like just we can draw like you said, we can draw parallels with encryption and decryption. So when we sign up to this, sorry, when we pay or sign in into these Netflix accounts, they have like they send the video files in the browser, and also uh, the session. In the session, you have these, maybe we can call it decryption keys. So decryption keys are embedded into the player itself. So it knows if this is the encoded file and this is the key, it will unlock and play the video. And if you don't have like your subscription has expired, so it will know that the key has expired, and it will not validate, and the files that came from the system, it will say like we cannot play that, or it will show throw some error saying please pay, make the payment first or something like that. So
Okay.
that's about DRMs.
Yeah, or yeah, we cannot screen record Netflix screens. We cannot present Google Meet to the Netflix. Those, I think, all are handled by DRM itself.
DRMs, yeah. So no, not in case of Netflix.
Yeah,
Any videos that are DRM
streaming.
protected,
Right, right,
maybe
right.
true for primes and everything.
Mhm.
Then the players. So the players that Akhil told about the Silverlight. So Netflix uses Silverlight to download decode. So here, this was the part I was talking about. The player knows that how it's going to decode that DRM protected file. So it's there only. So Netflix movies and desktop web browsers. The runtime is a plugin for the most web browsers, the players for the mobile phones and other devices such as V, Roku, etc. This paper, however, focuses on this when playing only on the desktop PCs. Netflix uses Dash Dynamic Streamer HTTP protocol streaming in Dash. Each it is encoded. several different qualities and divided into chunks. Video segments no more than few seconds in length, including takes around video chunk every time. HTTP. With each download, it measures its thread into an algorithm, determine the quality of the next chunk request, dash log the player to freely switch between different quality. Okay, so the player we talked about that it uses Silverlight, and for the context of this white paper, we will assume that we are talking about playing the Netflix on a desktop web browser. So there it uses Microsoft Silverlight as a player, and it knows it has the decoders for that encoded video, and also Silverlight is just a plugin. Maybe you can consider as a small program that is there in the browser itself. We can like add embed it into the browser itself, and also different devices such as with names like the Wii, Roku, and mobile phones as well. And this helps to play the video. Also, Netflix uses this dash. Dash is dynamic streaming over HTTP. So it's just an HTTP call, but like maybe optimized for streaming. That like if you use regular HTTP call, we will have to maybe got through for each connection. We'll again have to establish connection and then send request and get back the response. So it might be a little optimized for that part and get the chunks of the video. Also, coming back to the how video is received, so it's not like that you are making a HTTP call and you got the whole 2 GB or 4 GB
Video,
video
right?
file altogether. Yeah, it's divided into small chunks and small chunks of 4 seconds segment that I have read somewhere. Maybe yeah. So basically in seconds, maybe 2 seconds or 4 seconds, something like that. And then these chunks are like clubbed into your that local client via Silverlight, and then it plays all together. And also it says like Dash can switch between different types of qualities. So earlier we discussed that we can have HD video, we can have SD video, we can have 4K video. So assuming that you have some right now you have a 5G bandwidth or maybe like good bandwidth, maybe 10 Mbps per second. So now you can watch 4K. But if that bandwidth drops to 2 Mbps, so 4K for 4K there will be some buffering, like it will wait for the chunk to finish up, and basically there will be some loading time. To avoid that, it will just dynamically switch to a lower file quality type, and it will be handled by the dash itself.
Right, right.
So the previous, I
So
guess.
this dash is one of the most important thing in our whole discussion, that how this dash protocol is used for the streaming. And I got to know about how these videos are chunked, and these are chunked when I tried trying to inspect the network traffic of Netflix when I was streaming the video. So I was trying that how these videos are coming. So suppose we are seeing some images that we can see that there is an API call, and there is then image we can retrieve it, we can save it, we can download it. So I tried doing same
Mhm.
for the video. So I was trying to see that from where these Netflix videos are coming. So that time I knew that the videos are continuously coming in form of packets. So you can
Yeah.
draw parallel with like photons. So the photons are coming in the packets. So similar to that, these videos are coming into the packets, and each packets is come like of very few seconds in length, and of
Mhm.
as the photons of different energy levels can come, so similarly like that the small chunks of the video can come in different qualities according to the bandwidth of your internet. So the
Mhm.
internet of bandwidth is
Right.
being checked continuously. Suppose you are able to fetch these video, and we are able to suppose this is a 2 second video, and to fetch that video it's taking 1 minute. Then the algorithm will understand that your bandwidth is low or high or whatever, depends on the time take to get the video. I think that is the logic for that, I guess.
Yeah, absolutely correct. Redetermination algorithm, it
Right,
says.
right, right.
Yes.
So servicing a Netflix client, we now take a closer look at the interaction between client web browser and the various web servers. And here is the like how this video and chunks
Mhm.
from the CDN is coming. So,
Mhm.
and this is the manifest file which we'll discuss, that you can see few, XML kind of writing of the manifest file. But let's discuss once we finish this paragraph reading of the what is the topic? Serving a Netflix client.
Player.
Right, right.
Mhm.
So let me read it and you can explain about few of the things, Aditya. So the client first downloads the Microsoft Silverlight application. The client, we mean that it's not the user but the service. So the client first downloads the Microsoft Silverlight application from the movies.netflix.com and then authenticates the user. After authentication, the player fetches the manifest file first. It does not directly fetches the video. It first fetches the manifest file
Mhm.
from the control server at agmoviecontrol.netflix.com, based on which the it starts the download trick play data and audio video chunks from different CDNs. So as soon as it gets the manifest file, it knows that what kind of data of what bit rate of video and audio it has to download. So you can see these are the audio chunks and video chunks. So the timeline of serving in Netflix. So the number of seconds from start, you can see that audio chunks and these are coming. So the first the player and then manifest file, you can see the timeline. So suppose this is zeroth time
Mhm.
and this is 1 second, this is 2 seconds, this is 50 seconds, right? So the first player, it's calling the manifest file, it's getting the manifest file, and then it is getting the trick play, and from this manifest file this is deciding which audio chunk and which video chunk they have to fetch. Now uh, we are till that point from yeah, so they are using different CDNs to download that. Now Silverlight player download and user authentication, how is this happening is that video playback on a desktop computer requires the Microsoft Silverlight browser plugin, as Aditya told, that is a basic plugin. So as soon as we user clicks the play now button, which is the center of our screen, the browser downloads the Silverlight application and then they start downloading and playing the video content. You might have seen that as soon as you click the play button, there is a little loading button. So at that loading time, these whole things gets happen. If your internet is slow, you might have seen that loading button. So when that loading button is there, I think our program decides which manifest file to get and what like videos to fetch and what bit rates to fetch. So that is thinking. So that is loading part. So
Mhm.
yeah. So Aditya, will you be explaining the Netflix manifest file?
Yeah, okay. So manifest file. Netflix video streaming are controlled by the session of the specific files and client downloads. The Netflix manifest provides dash player method to conduct the adaptive video streaming. Manifest files are specific files printed according to the client's file. Okay, so basically before actually playing the video, the this Silverlight first fetches a manifest file, and in this manifest files, Netflix instructs like how what CDNs you are going to fetch the data from, and like for this adaptive video streaming, and yeah, the things about like how what metadata and different metadatas are also associated with this manifest file.
Right, right.
So that's about the manifest file. And the manifest files are client specific. They are generated according to each client. So they are different for the each client. Basically, for each user, they are different. And not only for each user. Basically, if you open Netflix over a different uh, two different browsers, that also treat as two different clients. So for that as well, you can have different manifest files. For instance, if user indicates a simple keyword representing a FAST26 encode video, it should format is included in the first file. The player indicates that it can only playback in the format only is included. Okay, so now if you are like, let's suppose if you are watching Netflix on Internet Explorer, somehow it still exists, and so it might not support H26 encoding, which is by far the latest encoding before H25, which is more optimized. So yeah, so and that cannot run or decode the H264 encoded video. So the manifest file will say that it can only like run these many types of the files. So now the player will know which CDN to call for which file type, and then from there it will take like it will be calling those CDNs and play the video. So that is also included in the manifest file. The manifest file is represented as SSL connection, hence content cannot be read over wire using packet capture tools such as TCP dump on Wireshark. We use files, for example, to plug in the extract manifest, extract manifest by the format contents, several keys, piece of information, including CDNs, looking at the trick play data, what audio video chunks, URLs for multiple particles, parameters, Okay, so what they are saying that these manifest file cannot be like it's not like we can cut through the network call and check what it's there in the manifest file. It's not like that. It is passed like it is encrypted and passed through the SSL connection. So SSL connection. Akhil, do you want to like establish what SSL connection is?
Yes, so SSL means secure socket layer connection. So it does not let anyone to tamper between your connections. So suppose you're a client and server. So between client and server, every sensitive information is sent through this SSL connection network. And SSL encrypts data, and so it is difficult to anyone to capture the data and see through it. And also it involves verify the device involved or who claim to be digitally signed. Yeah. So basically, it tells that who you are to the server, and then server identifies you. If it identifies you, it sends you data, and if does not identifies you, it says sorry. So so that is about the SSL connection.
Yeah, so basically what happens is before HTTP, like SSL only says that there are certain URLs that you might have come across that start with HTTP, but not HTTPS. So for the HTTP secure, so how the HTTP is secured, so that's where the SSL comes
SSL,
in
right,
picture.
right.
Uh, so the client, the web browser, like in this file also, you can. Akhil, can you like go to Excalidraw
Sure.
tab? Okay, so can you click on the log icon? This log icon of the browser
Oh, sorry.
just before. Okay, yeah, yes.
This connection is secure.
Okay, I cannot see the overlay because I think
Okay.
it's not only
Yeah, it does not
tab is
let
present.
you. So there is. Let me draw this so that everyone can
Maybe
see.
you can just like, screenshot that and paste it in the Excalidraw itself. That will be
Okay,
most
sure,
quick,
sure,
more
sure. Right, right, right.
fast.
Oh,
Windows
no, no,
Shift
no. If I
S
if
if
I
you
if I click, actually my hey, here this is
okay. Okay, so connection is secure. Maybe you need to click on that as well. No problem. So connection is secure basically, and cookies and site data. So in site data or in connection is secure, you can check that few certificates are available in there. So what
right,
are these
right.
certificates? So these certificates basically says the remote server that yeah, I am a valid client. Please send me the data or establish connection. So
Sorry.
that yeah, and these certificates are validated by the SSL servers, the SSL connection. So that's how the HTTP is secured, and you cannot just intercept those calls and check for whatever data is being sent or received from the client and server. They are just garbage in between if you don't have the encryption key.
Okay.
So coming back to the paper,
So this is the connection
yeah,
is secured thing.
yeah, it says that connection is true and this it had been authenticated. So SSL has authenticated this. It might have checked for the different certificates, SSL certificate, and authorized it.
Right.
Coming back to the PDF, specific generator. Okay, so where we were, SSL connection. Now, so how did they got to this file? They said they use some temper of the Mozilla Firefox, and they are able to fetch few of the
Manifest
few
files.
part of this few chunks, and there we can see the location and the different CDNs and yeah, things like that. A chunk of that whole file. Can you scroll a bit? Okay. a bit more. Like, we were in the this Netflix manifest file and we haven't completed. So yeah, so it's saying like it's in like Akhil said, it's in XML format, as you can see in the above picture as well. So and yeah, so they use some Firefox browser tamper data plugin to extract this manifest file and got this information. So yeah, so this manifest it says that these manifest files include some information such as the what are the different CDNs, what are the different locations, trick play data. So we'll come to the trick play in next maybe point after that. So trick play is basically when you seek to a certain point of the video. So that
Thumbnails.
so that is
Yes,
yeah. So that
thumbnail
is
parts.
yeah, thumbnail and etc. So that is handled by the trick play, and then also the chunks of the actual URL of the video chunks is also present in the manifest file itself, and then the quality levels obviously. And so next is three CDNs too. Yeah, again back to multiple CDNs, like it uses three CDNs and they are again that's there in the manifest file itself. So we are mostly encountered it thrice. So now the trick play. So Akhil, do you want to take it over? The trick
Yeah,
play
but
part.
let's first go to the manifest file, right? So this is the manifest file you
Okay.
can see, right? So there are multiple, like you can see three nodes of the XML file where the data is stored. So this level 3 is one of the CDN provider, Limelight is one of the CDN provider, and Akamai is one of the CDN provider. So there are ranks. So you can see that 1, 2, and 3. So the first time when you will load Netflix, the data will be fetched from level 3. If the level 3 like goes down, then Limelight comes to the picture, and then if the Limelight goes down, then the Akamai will come to the picture. Now
Right.
that conclusion will come in later part. So
Hmm.
these are not only the information which are present in the manifest file. There are more information, but due to like unavailability of that, they were able to get these data only from the temper monkey kind of plugins from the Netflix. These are only present. So suppose there will be more, nodes like NCCP bitrate or NCCP video quality, NCCP, and etc. And that will be containing the information about the video. Now we are coming to the trick play part. So trick play is nothing but when you scroll through your video, so to see few of thumbnails, to navigate to some point of your video. So these thing is handled by the trick play. So those are basically the thumbnail part, which provides you a sneak peek to your whole video. So suppose you have lost your video uh, in internet failure or anything. This is provided by Netflix that it plays from the last time you have paused or left. But suppose this feature is not present, then how you will be going to scroll it? So suppose you are scrolling it, you see a few parts of that scene, then you will be able to identify that. So that thing is handled by the trick play. So now Netflix Silverlight Player supports simple trick play such as pause, rewind, forward, and random seek. So a random seek is that which I am talking about, and this pause, rewind, and forward are the trick play terms. Now trick play is achieved by downloading a set of thumbnail images for a periodic snapshot. Suppose that periodic snapshot is of 10 seconds, 20 seconds. The thumbnail resolution, pixel aspect, trick play interval, and CDN from where to download the trick play are described in the manifest file. So everything which the player need is is written in a book called manifest file. Everything will be referred to that manifest file, and then manifest file will be able to so that manifest file will be able to use uh, will what I wanted to say, that manifest file will be used to fetch all the data from the servers or the CDNs. The trick play interval for the desktop browser is 10 seconds, and multiple resolution pixel aspects for trick play are provided. Right. So as according to the bandwidth, the pixel resolution of the trick play will be provided. Now audio and video chunking downloading. So chunk
So
downloading.
trick play. So trick play, maybe you can assume like without trick play, it's like using this free version of the Spotify account where you cannot seek a song or you
Right,
cannot
right,
skip
right.
a song. You have to watch it all together by
No
the time it
control.
ends. So
No control. It's like
no
watching
control.
TV. It's
Yes.
like watching TV, right? So you do not, skip advertisements. You do not go to the previous scene. You do not, go to the next scene. You have to. Time will be your trick play.
Control.
Now,
Okay. So audio and video chunk downloading. So audio and video chunk downloading. I showed him the figure two. So the figure two was like the timeline that we saw, that first the manifest file loads, first
right,
the this silver light loads and manifest file loads, and then things happen, and then audio video chunks. So back to that. So download sessions are more frequent in the beginning, so the player buffer. Restrictions on buffer. So it says like in the initially the chunks are various chunks are downloaded all together just to check like what is a player buffer and how it performs to check that. Then once they are sufficiently filled with the downloads become periodic, the interval between the beginning two consecutive noise is 1 to 4 seconds. The length of the playback typically of a typical chunk. Okay, so now it's established that yeah, this much buffer is good. So now it sets that after consecutive 4 seconds, it will fetch the new chunk and show it to the user.
right.
Basically, what it does is if I'm watching 2 hour video, then maybe like first 1 minute or 2 minute maybe downloaded all together, and then next buffer is downloaded periodically every 4 seconds. The next chunk is downloaded periodically.
Right.
So Memphis Bang has multiple audio and video quality levels for which word you are indicated. So yeah, so the this Memphis files contain the URLs that we have already saw. Then you scroll it again.
Yeah, this is the
Also
manifest
there
file
are
with the bit rate.
yes. So the bitrate and the video file basically does it supports player ready H20 H264. Here we can see that yeah,
Encoding part.
that yeah, this player can read like play this type of a video, and then width and height. So here we can see that it's maybe a 480 or something like that video resolution, 480p, close to 480p. And then also expiration of this, and then what is it, download URLs. So these are the actual links for the CDNs that starts with HTTP from yeah,
And you can see the
for
CDN
each
ID as well. So the CDN
ID
ID
attached to
will
it.
match to the particular CDN which is of the ID. You have seen here, right? So these are CDN
Yes.
IDs saying 649. So according to that, it will redirect to the CDN IDs it belongs to. Now we are coming to the user experience rating. I think we are done in the video downloadable on quality level, right? So, or you want to explain more about this manifest file?
No, that's that only. Major part, the highlight is that it will first load a few buffer, like maybe 1 minute or 2 minute of the whole video, and later on it will periodically send the request in, like to fetch the chunks in periodically after every 4 seconds. So
Right, right.
that's the major highlight. As you-
So now user
Yeah.
experience reporting. So the user experience reporting is very significant. So after the playback starts, Netflix player communicates periodically with the control server, which is agmoviecontrol.netflix.com. Let me try to open this if we are able to open something or not. So yeah, we can't open that. So based upon the keywords such as slash heartbeat and slash log blob. So slash heartbeat is telling that it is alive, and slash log blob is for the logging purpose. Now, in the request URLs and the in the periodically of the communication, we conjecture that there are periodic keep alive messages and log updates. Sorry. Uh, yeah. So, periodic keep alive messages and log updates. However, the actual message that we have extracted by using temper data do not appear to be in clear text, and hence we cannot verify it further. So that the data which they have extracted from the temper data are, like in gibberish format. So they haven't extracted what exactly it meant, but they have drawn that there is a keyword less slash heartbeat and slash log blob, which will be able to tell the server that user is alive, that user is watching, and the log updates for what is happening. So if suppose you are seeking backward, then there will be a log. If you are moving forward, then there will be a log. If there will not backward and forward, then the log for your streaming will be like recorded. Now manifest
Yeah.
file analysis. So we have already, like few pointers about the manifest file, that what is happening. So you can see that manifest file is the whole, what we can say, the run book or logbook for the whole process. So from where, which CDN to get the video, what quality of your video. So if I'll say that suppose this video is streamed on Netflix, then the manifest file will contain different kinds of data if you are traveling. So suppose you are in a Wi-Fi network, then there will be data of HD, and suppose you are in a low bandwidth network, then there will be suppose 420p, then 360p, etc. So there will be different layers of manifest file you will be seeing, and that manifest file is now analyzed by the what we can say, the researchers. Now a manifest file is delivered over the SSL connection. We use temper data plugin, blah blah blah, etc., which we already discussed. Now we are interested in understanding how geographic location and client capabilities and content type may impact the streaming parameters. So suppose Aditya is in Pune and I am in Gurgaon. So is this location is impacting the manifest file? And suppose Aditya is using iOS and a high bandwidth location, and I am using a Windows laptop with like low what we can say, low configuration. How it is affecting the streaming capabilities and streaming parameters. Now uh, for the data they have used what, 6 different user accounts and 25 movies varying on the popularity age and type, and they have extracted few informations. Now so they have also configured client browser using squid proxy servers running on US universities, since they have more bandwidth. Now CDN ranking and user accounts. Netflix manifest file, here we'll get to know how CDNs are ranked. So Netflix manifest files rank CDNs to indicate which CDNs are preferred, and for a given user account, what information they have extracted is that for a given user account, the CDN ranking in the manifest file remains the same irrespective of the movie type, computer time, and locations. So they are fixating the CDN ranking, so they are not calculating the CDN ranking each time. A user is seeing different movie, a user logging into the different time and location, just to save some computation. Now we can also observe that CDN ranking for user remains unchanged for at least several days. Okay. So they have also drawn the information that the CDNs are not being changed each day or each hour, or they are remaining same for several days. As now, this is the information they have extracted from the manifest file. Now, audio and video bit rates. So you can go to this pointer, Aditya.
Yeah, so that's again the same thing, like the bit rates and the audio bit rates. Like we have different bit rates for audio. Like way back in maybe when we were in school, we used to fetch download songs from
Right,
Songs
right,
PK, so
right,
that's 250 kbps, and maybe less than that 240 kbps. So for different kbps, that different bit rate, file size was used to be different. So maybe 240 kbps file size somewhere around 1 MB, and for 320, since it's a high quality, so it may be of 9 MB. So similar fashion, these informations are embedded into the manifest file, and the later information about the what are the different bit rates and what are the different qualities it supports. It's just you can the user viewers can get through this chunk and read that. It mostly summarizes. I have just summarized it.
right, right.
Yeah, just
Now the CDN selection strategy. So how they are selecting the CDN. So as we lower the available bandwidth for the first CDN while leaving the other CDNs intact, we notice something interesting. Instead of switching to a different CDN which is not throttled, the client keeps lowering the bitrate and states with the first CDN. Only when it can no longer support even the very low level quality, it switches to the next CDN. So what it says that the CDN is not like changed dynamically each time. So it goes to the, suppose you have started streaming in the 4K format, and suppose your CDN is AWS or Cloudflare suppose. So until unless the Cloudflare CDN is not able to provide you, suppose 144 kbps bitrate of like a video, until that point Cloudflare will be your CDN. If even if that is not able to like supply that video, then the next CDN of suppose Akamai will be used. So they have drawn this uh, summary from the analysis and how the CDN
Hmm.
strategy is being used. So you can see the map of US. So these A, C, B are like best CDN at each vantage point are drawn here. So I don't know what they are using for the this is a bitrate limelight number of seconds from start. So you can see that the black one is level 3 CDNs. So 0 is the second. So suppose 4000 or 2500 bitrate is supplied. Now it is had lower down to 2000, then it has lowered to 1000, then it has lowered to below 500. And then only they have shifted
Yeah.
to a different CDN which is limelight, and then limelight has started performing from the 2000 kbps. As soon as the limelight starts giving you bandwidth less than the 500 bitrate, then only they are switching to the Akamai, and now you can see that Akamai is of 2500. If that is really
And
optimized, you can see that it can switch the video, it can easily play the video in the 2000 range. You can see that all the CDN is able to provide the 2000 kbps. So now we'll get to know how they are like solving this problem to reach to the 2000 average kbps. So over to you, Aditya, for the performance measurement, CDN performance measurement.
yeah, so we are done. And before that, like we have like used, I don't know, I lost count how many times we used the term CDN. So before everything else, I think let's get to this term, like what
Okay,
is actually a CDN.
right,
So
great
I've
point.
shared you a like link, maybe like you can present that,
Okay, okay,
so
I'm
we can
opening
get
this.
through what are CDNs and what they are exactly.
Okay, I'm opening this. So yeah, are you able to see the uh, screen of Excalibur?
I'm
Oh,
still able to see the PDF file only.
okay. I have
The
actually
edges.
right. Edge is being shared.
You can just open your own. Okay. Uh, yeah. Try pressing Alt R. So it will get to the read only mode. Yeah. Okay. Now span it to the right. Maybe I have added in the right side. Yeah, this one. Okay. So a world without CDN. So basically, like in context to the whatever we have read so far, like how Netflix downloaded chunks from for each video and then shows it via the player. So let's suppose for each chunk, it make an HTTP call using the dash what methodology or protocol, and then each chunk takes 700 milliseconds to 1 second of round trip, like getting that response. So without CDN, maybe there are multiple hops. First, the Netflix, when you will click on a video, then it will resolve to the actual CDN. And for before getting that, not CDN. Let's suppose there is no CDN. There's a world without any CDN. So you have to get to the Netflix server itself, where it's holding the video public URL in the S3 file maybe. So first you have to resolve the Netflix domain name from a DNS server. Then again it will hop to some another router in between, and then again it will hop to S3's actual server, and then from there you will get the file. Now again these four hops back to get the response from the server, and this is for just a single chunk. Now, for a 2 hour long movie that you are watching, for let's suppose there is a 5 second, each chunk is divided into 5 seconds. So there are 1440 chunks, and so that's 1440 HTTP calls, and that is into 700 to 1 seconds each. So that will get you to a number, and that is not likely to be a good number, it seems, for a 2 hour long movie. And now let's say what happens when there is a serial. So you got to know that there will be series of multiple calls,
Right, right,
HTTP calls, right? There is no CDN, and you have to, for each HTTP call, you have to do these four hops, and then you will reach the server. And again, you have to these four hops to get to the client with the served response. Now let's see what happens when there is a CDN. That is our word. So you can see that CDN is distributed all across geographical locations. Now the one which is closest to us is this green CDN, and C1 which we are watching. Now there might be a single hop, let's suppose, because DNS will know that this is the CDN's IP address in the single hop. So maybe one or two hops to that CDN. And I have like these numbers are taken out from the actual Netflix developer tools page. So the CDN part basically it resolves the query, or it sends a response in 50 milliseconds. So that's already 90% of gain. So 86 to 95% faster. Basically, I have took like what will the 50 milliseconds of the 700 seconds and 50 milliseconds of 1 second, and so on and so forth for the 100 millisecond to 701 second. So that's around 86 to 95% faster. Because so what CDN basically plays here, CDN, we don't have any computational things over CDN. CDN, you can
right.
assume it is it's like a Google Drive where you have like uploaded a file, and you can have a public link, and whenever you can share that public link to anyone, and the one CDN which is closest to you will serve that link, and it will be very faster than the getting to the your actual
Server.
server and then that file. So
Right,
that's
right,
how serial is very beautiful, and that's how it serves very good.
right, right. I want to add few pointers in this. So suppose you are in India and your server is in US, right? So suppose
Yeah,
there are multiple servers. So actually, request your travels by wires, right? So it
yeah,
actually is
under
traveling from point A to point B. Now, the server, it takes a lot of computation and cost to run a server and, do the computation part. If you are fetching your videos again and again from the server, it is taking time first, plus computation part. Sorry, let me
yeah. So
reduce this.
processes are running over
Yeah,
it.
so computation
You
part.
have to speed up the process.
So instead of doing some, useful stuff, you are just using your server to get the data. I don't think it's a good, a trade-off. And one more thing is that servers are, if you want to make your server secure. So by secure, what I mean is that suppose there is your server and you are bombarding it for, suppose you are watching Breaking Bads, right? Now you are a very rich person. You are making a different server for each of your movies, right? Even if there are, 1,000 people wanting to see the Breaking Bad, your server will be having a lot of load, right? So this unnecessary load will increase the traffic. I know you can, use load balancers and number of fancy terms to balance your load, but one more thing you should know is that you will be very prone to DDoS attacks. So these DDoS attacks are can be easily, I think, avoided by using CDNs. So CDNs are those which can, bear a lot more, what we can say, heavy load than the servers in a cheaper way, I think. So servers are costly to run instead for serving data, obviously. So CDNs are designed for serving you the data only. They are not for any computation thing.
Yeah,
So that's why they are cheaper and more secure than the servers. So you can easily avoid the DDoS attacks, which is, which was very prone few, I think, decades or years ago.
years back. Yeah,
Yeah, so you often see very often DDoS attacks. Even today, when we open sites, when there are results of Indian exams are happening, the slides are slower, but they are not, getting DDoS attacks. But earlier they are, just they will not be available for whole days. So I think that is one more point regarding the CDNs. And there are two types of CDNs.
Yes.
One is push CDN and one is pull CDN. So push and pull CDN, what are those? So pull CDNs can like fetch few information from the server as well, or push are from the server. Push can provide few data or information from the server, and pull will be only like fetched by the client. So give me this data, give me this data, give me this data. So I think that's about that. If I have written anything about the push pull, yeah. Server is responsible
Yes,
for the
yes,
push
right.
CDNs and pull call to server for some of like instructions. Now a CDN are not only used for like serving your videos and audios. There are static files like HTML and etc. are like used by server only, CDNs only. So that was the first thing. I think CDNs were designed for like serving the static files, and then it is scaled to videos and then images and all those stuff. Now,
Yes.
yeah. So now these one more thing which we talked about, storage in the manifest files, as Aditya told. So suppose this is your video of Breaking Bad. Now there will be n number of qualities in which it will be stored. Suppose quality one is of HD, quality two is of SD, quality three is of 144, and suppose this is zero. No, nothing. Now it will be stored in different bit rates, B1, B2, B3, B4, and the same thing will be stored in different CDNs. So suppose this CDN is of level 3, and suppose this CDN of Cloudflare. Now if level 3 will reach to the point of Q4, then only the whole data will be fetched from the CDN2, right? Hello.
Mm, no, I think like yeah, each video quality file is for each bitrate is there on individual CDNs, the three CDNs. But when the bandwidth of the CDN one
Okay, okay,
has
okay.
reached to Gbps, then it will switch to another CDN.
No, no, I think the bandwidth is not. Suppose there is a B4 bitrate, right? So if the B4 bit rate will be very low from the CDN, will not be able to serve, it will degrade the video quality to SD, right?
Okay, you're saying like that. Uh, okay, okay. Yeah. So basically, what CDN what they have configured is you can serve any of these files, any of these chunks. It doesn't matter. Like yeah, you if your bandwidth is low, you will be reaching to 144p eventually. But you have to make sure that the network bandwidth of the CDN exiting the CDN should be more than 100 kbps. If it's less than that, then it will blow the CDN one and it will point to CDN two.
Okay, okay. Now moving to
Um,
this part, CDN performance measurement. There are a few questions.
performance measure.
There are a few
Yes.
questions they have asked and they are tried to solving it. So how does each CDN perform? Can the selected CDN serve consistently support the bandwidth needed for high quality streaming? How the different CDN compare in terms of performance? Is any CDN clearly better or worse than others? How far is the current Netflix assignment strategy from optimal? Is it possible to improve the assignment strategies? And around these four questions, research people continues. And now, you want to explain all of these, or
Maybe it will get too much overwhelming for this
right, right?
video.
These are just like
More technically, yeah, technical things you can read there. The reviewers can read it themselves.
no, no.
They are
They
just
are
like
just research. They are tried different CDNs in different manner,
how they
and
are
then they have
performing.
corrected the data. So that is about that. Someone is calling me.
Basically, you can think it as like you have run different experiments for each CDN, and then you have few data like how it has performed, and then you have like an algorithm to determine which CDN will perform on which bandwidth for which geographical location. So
Okay.
that's they have like tried to conclude from
Yeah,
these
we can just
experiments.
read the headers of whatever they have written. So they have measured in different, what we can say. So overall CDN performance, they have measured their daily bandwidth variation. What is the variation of streaming the video daily? And then they have a
Mhm.
variation in instantaneous bandwidth. So they have tried changing the bandwidth, and then they have seen how CDN is performing. So you can say the 1 day
Okay.
average bandwidth over time is this. So CDN A, CDN B, CDN C, you can see that CDNC is very low, so zero, almost touching zero. Now they have also plotted graph of different bandwidth over 1 day average bandwidth at Planet Labs node over time. So the Planet Lab over time is situated in a US university setup. So they have tried these blend with fluctuation graph, and now
Mhm.
there is a room for improvement. So from here we can resume again. So the room for
Mhm.
improvement is, although this cannot be done in practice since we do not know the instantaneous bandwidth beforehand. Sorry, we'll read from here. Alternate video delivery strategies. So alternate delivery strategies they have figured out is that a room for improvement, and there's one more thing. Sorry, yeah, measurement based CDN selection. So the first strategy they have discussed is that what happened to the paper. So the given the instantaneous bandwidth trace, the optimal CDN selection strategy is to choose the top CDN at each point of time. So they are saying that we can select the top CDN at any particular of time, but they contradict as they say this cannot be done in practice since we do not know the instantaneous bandwidth beforehand. So if you do not know the instantaneous bandwidth beforehand, then how we can switch and tell, like to go to this CDN and fetch the data. So now this optimization works theoretically, but doing this, uh, in practical manner is a guesswork, I guess. And by the guesswork, wherever we see the guesswork, it says to choose the CDN from a trend. Suppose you have data for a past 10 years for the same CDNs, then I think then you can predict the particular CDN will be up at that amount of time with most probable time. Will not be 100% sure, but the most probable time, maybe deploying a basic ML model to choose between three CDNs.
Yeah.
Now another is that measurement based CDN selection. So Uh, so what is the measurement based CDN selection? That we propose to have the player conduct the instantaneous bandwidth measurement multiple times at the beginning and they assign user the best performing CDN. So we have already discussed that there are first more calls to the CDN to get the data when the video starts streaming. So they are saying that at that time you will try or calculate, you will do some calculations to get the best performing CDN. And I think this solution is more preferable, and this can be easily what we can say implementable at the time. So and one more is that they are saying that using multiple CDNs simultaneously. So suppose you are getting the same data from multiple CDNs, and whoever provides the best data you serve it to the client.
Yeah.
So I think these three are their conclusion. And now we are conclusion part. Can you conclude this?
Yeah, sure. So, by the conducting lightweight measurements, the beginning of the video clip, which is the best performing CDNs can improve the average bandwidth more than 12% of static CDNs. So, industry using all three CDNs and releasing improve. So, it's saying basically like if we statically assign a CDN to a particular client, then it could have used more than 12% of uh, the bandwidth, and uh, on an average like it could have used more than 50% of the this multi CDN
Mhm.
strategy. So by implementing the multiple CDN strategy we have reduced the bandwidth. So like for most of the cloud services, the network leaving, there's term called egress and ingress. So ingress is basically whatever traffic that is incoming, and egress is whatever traffic that is outgoing.
Mhm.
So your virtual computers or virtual computers that we buy on the Amazon or GCP or wherever, there you might have a slight slime line saying that this bandwidth will be allowed. And for S3 as well, it's true that this much amount of ingress and egress is free or is in the range of this much amount, and going beyond that bandwidth range, you'll have to pay more. So
Okay.
yeah, so achieving 50% less in this bandwidth, it's like a huge cost cutting they have achieved,
Okay.
because it will ultimately draw the like reduce their bandwidth, so ultimately reduce their cost of the maybe clouds or CDNs or whatever
Okay.
whatnot.
So Aditya, one question I have, that suppose you are calling three CDNs at any given point of time. So isn't there any cost associated with using CDNs for Netflix?
CDN's bandwidth for that context. Yeah, maybe. So I don't know about the costings of the CDNs or how they work, but I have closely looked over the S3s or any blob storage.
No. Okay.
So or maybe for the databases as well. Like for databases, you know that the RAM and the
Hmm.
amount of data that you can store, they are directly included in the cost. But there is also a network part there, because let's say your database has grown into petabytes of data. Now you are fetching petabytes of, you are loading millions of rows in the disk, from the disk into the RAM, and then you are doing all your query, like maybe
Right. Right.
ordering or including the where clause and all those stuffs. And this data, whatever the end data, maybe it could be JSON or anything that is being transferred to you, the client, maybe the in this case the server is the client. So this server is fetching this data via networks only. So now data from the database, what maybe 100 kilobytes of data has been released to this server. So that is counts against the bandwidth of this database that that has been hosted over GCP or any cloud. So for that, when it exists to certain limit, they are charging. Now reducing it to by 50%, let's say, according to their strategy. Not maybe true for the this database part, but continuing with the example. So now we have like capped it in that range where we don't have to pay more money, where we don't have to burn more money. So that's the conclusion. Like they have reduced the bandwidth price. Or else, if like they might be like, if they going with a static assignment, then they have to like pay more, because just with this for the same watching videos. So that's they have
Okay.
like reduced. And
Okay. Okay.
as per
Got
my
it.
understanding, like what do you think? What they are trying here?
Yes, so I think like we can discuss after reading few things about how CDN costing works. So, like
Mhm.
otherwise it will be like throwing stone in the dark. So the new phrase I just tried. So I think this was a really great discussion, Aditya. So we got to know about different things, like C names, CDNs, and the dash protocol of the
The protocol,
Netflix.
the
So
DRMs and
right, right, right.
what?
So I'm ending the stream. So thank you, everyone. It was a great
Yeah.
time talking, and we'll be recording next time. Bye bye.